Welcome to David Alexander Maths Tuition. This is chapter 9e, solving triangle problems. So the diagram shows two sheet pens that are separated by a fence AC. Find the sizes of angles DAB and BCD. Okay, so DAB is going to be this small angle plus this small angle. So I'm looking at the triangle DAC. I've got three sides marked, so I can use the cosine rule. So the cos of DAC equals 15.9 squared plus 11.8 squared take away 9.3 squared all over 2 times by 11.8 times 15.9. So therefore the DAC is going to be the inverse cos of whatever answer our calculator gives us there, and that should give us 35.48. So I can do exactly the same thing for the triangle ABC. So the cos of angle CAB is going to be 15.9 squared plus 5.6 squared take away 10.4 squared all over 2 times 5.6 times 15.9. So therefore CAB is going to be the inverse cos of all that stuff, and I'm getting 8.74 degrees. Okay, therefore DAB is going to be these two values added together. So 35.44 plus 8.74. Sorry, no, it wasn't 44, that's an 8, isn't it? 35.48 plus 8.74, I'm going to get 44.22 degrees. Okay, now I could use the cosine rule to work out these two angles, but I always recommend using the sine rule instead of the cosine rule if you've got the opportunity to. We know this angle here, so we can say that the sine of 35.48 divided by the side opposite it, 9.3, equals the sine of ACD divided by 11.8. Therefore, 11.8 sine 35.48 over 9.3, running out of space, it is the sine of ACD. So let's just grab our calculator. 11.8 multiplied by the sine of 35.48 divided by 9.3 equals 0.736. So I'll inverse sine that answer, and this angle here is 47.43 to 2 decimal places. Okay, I'm going to use the sine rule again. So I'm going to say that the sine of BCD over the side opposite it, 5.6, is the same as the sine of 8.74 divided by 10.4. Therefore, the sine of BCD is going to be 5.6 times the sine of 8.74 all over 10.4. So 5.6 multiplied by the sine of 8.74 divided by 10.4. So the sine of BCD is 0.08, so I'll just inverse sine that, so I've got BCD. So BCD is 4.69 degrees. So if I add 4.69 and 47.43, I've got this angle here, which is 52.12 degrees. Okay, so for the next part of the question, we need to find the total area of the two sheet pens. So we know that this angle here was 35.48 and this angle here was 8.74, so we can use the sine rule. So for the triangle ACD, it's 1/2 AB sine C, so that's 1/2 times 11.8 times 15.9 multiplied by the sine of 35.48. Okay, so 0.5 multiplied by 11.8 times 15.9 times sine 35.48. So this is 54 I'll just call that 45 square meters. And I'm going to do exactly, well, a pretty similar calculation for ABC. So ABC, that's going to be 1/2 times 5.6 times 15.9 times the sine of 8.74. Remember, when you're using the sine rule for area, it's an angle sandwiched between two sides. Easy to spot once you've done a few. So 0.5 times 5.6 times 15.9 multiplied by the sine of 8.74, and that is 6.76 square meters. So therefore the total area, just these two added together, easy peasy, 6.76 plus 54.45. So we're getting a total area of 61.21 square meters. Okay, so now we want to work out the length of the diagonal DB. Okay, so this is this length here, and we know that this angle here, DCB, is this was 47.43 and this was 4.69. So 47.43 plus 4.69, the whole angle was 52.12. Okay, so let's just mark in here that the big angle there, that is 52.12 degrees. Okay, so now I'm going to use the cosine rule again. Luckily it's the cosine rule for a side length rather than the cosine rule for an angle, which is a lot easier. So we remember a squared is b squared plus c squared minus 2bc cos of a. So we want a, so that's going to be the square root of all that stuff. So it's going to be the square root of 9.3 squared plus 10.4 squared, take away 2 times 9.3 times 10.4 times the cos of 52.1, that's a 2. It's the trouble with these graphics tablets, hard to write very clearly sometimes. So grab the calculator, 9.3 squared. So square root of 9.3 squared plus 10.4 squared, take away 2 times 9.3 times 10.4 times the cos of 52.12, don't forget to close the brackets, and we're getting 8.71. Okay, so dB is 8.71 meters, and we're done. So a lot of these triangle problems, it's just a question of just combining the two sine rules, one for angles and sides and one for the area, and the cosine rule. Try to prioritise the sine rule over the cosine rule. That would be my advice, as it's a lot easier to use.